Double elimination can happen whenever I have two halogens that are adjacent with respect to each other. The term vicinal, we use it whenever any two functional groups are adjacent with respect to each other. Here I have two halogens, so it's going to be vicinal dihalide. The reaction is going to carry with a base, and the base is a strong base in there. We can use bulky bases as well. So if we look on our table for our table in there, we can use the strong bases. The best strong base to use is the amide base, which is the NH2 base. The nitrogen is more electronegative or less electronegative than the oxygen. So the nitrogen is going to be more basic than that of the oxygen. With these types of reactions, we don't use oxygen bases unless if we want to use a bulky base, then we can go ahead and do that. You can use either a bulky base or LDA or potassium tertiary butoxide, or you can use the amide in this case. And the idea here, you're performing the elimination twice. Every time the base comes, it takes a hydrogen and an X. You form your alkene. The alkene here is going to be the intermediate, and then the base is going to attack again. It's so hard to stop the reaction because as long as you have a hydrogen and the halogen, the base is going to keep attacking to do the elimination, and your final product is going to be an alkene. So let's have an example over here. Base is going to come and is going to take the beta hydrogen in there. Okay, so base is going to come, it's going to take the beta hydrogen, it's going to form a double bond, and the halogen is going to leave. The mechanism is going to proceed by E2 reaction. So if you are showing the E2 reaction, it's better to show that the hydrogen and the halogen, they are anti-periplanar with respect to each other. So if this bromine is in front, then this hydrogen is going to be at the back, so that the base can come and take this hydrogen, form a double bond, and the bromine is going to leave. So you're going to end up getting your first alkene in this case, and then the second elimination is going to be, again, the base is going to come and take the hydrogen, form a triple bond, and the bromine is going to leave. And you're going to end up getting your alkyne product. The total reaction is this. So you used excess of the sodium amide. So this is how you write it down, excess NaNH2. And the solvent can either be polar protic like ammonia, or you can use a polar aprotic solvent like DMSO or DMF. The handouts for both the substitution, elimination, those two handouts in there, you can find them on eCampus. Please use them whenever you are working with the problems, and you can use them in the exam as well.